Modern cardiovascular medicine has a highly effective tool at its disposal. A class of drugs called PCSK9 inhibitors are capable of crushing a patient's bad cholesterol, LDL, by over 60%. This line chart tracks that impact, showing a patient's cholesterol levels experiencing a steep, rapid drop. These treatments can drive LDL safely below the 20 milligrams per deciliter mark to aggressively prevent heart attacks and strokes. But cholesterol itself isn't inherently evil. It is actually an essential building block for the human brain, playing a vital role in building cell membranes and insulating your nerve endings. Which leads to a highly logical fear. If we aggressively scrub cholesterol from the bloodstream, are we inadvertently starving the brain of its core materials and triggering dementia or Alzheimer's? It's a terrifying prospect for any patient facing long-term medication. To determine if this treatment is actually safe, top-tier cardiologists demand a rigorous 3-part standard of proof before prescribing it. We start with spatial biology and the concept of the two-economy system. The human body manages cholesterol resources in the systemic bloodstream and the central nervous system completely independently. This illustrates the blood-brain barrier, a rigid wall isolating delicate brain tissue from circulating fluids. Systemic LDL particles physically cannot cross over. Therefore, low blood cholesterol cannot drain the brain's supply. Instead, star-shaped astrocytes act as internal factories, synthesizing all required cholesterol locally. On top of that, the drug molecules used in modern cholesterol therapies are physically massive. Even if they tried, they are generally too large to penetrate an intact blood-brain barrier anyway. The fear of starving the mind is biologically unfounded. You cannot deplete a closed system that produces its own independent food supply. Moving past cellular theory, we can look at a natural human experiment running at a massive scale: human genetics. Millions of individuals are born with a specific genetic variation that naturally limits their PCSK9 activity. This gives them astonishingly low LDL levels for their entire lives. If extremely low LDL caused dementia, this specific population would show clear, widespread cognitive decline. Instead, genetic data confirms they maintain perfectly normal neurocognitive function. This lifelong exposure provides robust, real-world evidence. The human body is fully equipped to thrive with ultra-low cholesterol from birth straight through to old age. The final tier of proof comes from randomized, large-scale clinical trials. The gold standard here is a massive cognitive substudy known as Ebbinghaus. Researchers prioritized hard data, utilizing objective, rigorous cognitive testing on nearly 2,000 patients over an extended period. This chart tracks those results. Whether patients had ultra-low LDL or a placebo, the results showed zero meaningful difference in memory or cognitive performance. When proven theoretical biology, lifelong human genetics, and rigorous experimental trials all align perfectly, the medical community can definitively rule out dementia as a risk. Still, some patients do report feelings of brain fog or concentration issues when starting new medications. Those symptoms are real, and they shouldn't be dismissed. However, zooming out to population-level data shows these issues are consistently linked to other culprits, like sleep disruption, stress, or thyroid issues, rather than a brain starved of cholesterol. The modern lower-for-longer strategy effectively protects the cardiovascular system while remaining safe for the mind. Our bodies possess an elegant biological firewall. It allows us to aggressively eliminate the cholesterol that stops our hearts, without ever sacrificing the intellect that makes us who we are.